I hope you all can see my screen and I'm clearly audible to everyone.
Yes, ma'am.
Okay, great. So we'll start with this session. This is the sixth problem solving session for the course Environmental Chemistry and Microbiology. Uh, so this would be the last session for the chemistry part. From the next session onwards, we'll start the microbiology part. So in this session, we'll be discussing about radioactivity, radioactive decay, half-life, everything related to those topics. Okay. The course instructors, are Professor Anjali Pal and Professor Sudha Goel from IIT Kharagpur, and I am Shrija Ghosh, a PMRF from IIT Kanpur. So I have prepared certain questions related to your assignment questions, and I'll help you solve those questions. I would like you to answer the questions first, and then we'll have a discussion if your answer is correct or wrong. There are certain numerical questions in this session, so I would request you to solve the questions when I ask them, and I request all of you to answer the questions. You can write your answers in the chat box. If you have any doubt, you can either write or you can directly unmute and ask me. Any doubt related to the questions that I am discussing, or any doubt related to the general topic in itself, you can ask me. I'll try to help you out. Okay. So starting with the first question, question number 1. Among alpha, beta and gamma particle, which one has the highest penetrating power? Among alpha, beta and gamma particles, which one has the highest penetrating power? Options are option A alpha particle, option B beta particle, option C gamma particle, and option D all these particles have equal penetrating power. What do you think would be the correct answer? I request all of you to write the answers in the chat box and then we'll have a discussion. Which particle has the highest penetrating power? Okay, I already see 3 people have answered option C, that is gamma particle. What about others? Okay. Anyone else wants to answer? Okay, let's see the correct answer. So all of you are saying option C, that is gamma particle. That is the correct answer. So gamma particle has the highest penetrating power. So he's the penetrating power of all these 3 particles, so alpha particle, beta particle and gamma particle. As you can see, alpha particle has the least penetrating power, 0.01 mm of aluminium foil. Beta particle has the medium penetrating power of 0.1 mm of aluminium foil, whereas gamma particles have very high penetrating power. It can penetrate up to 8 centimeter of lead. Okay, so this is just to give you a perspective. Like if you imagine a aluminium foil, you can imagine 0.01 mm of aluminium foil would be a very small distance that alpha particle can penetrate, whereas gamma particles can penetrate 8 centimeter of lead. So just for the perspective purpose, this is mentioned. So gamma particle has a very high penetrating power as compared to alpha and beta particles. Okay, moving on to next question, question number 2. I hope the previous question is clear to everyone. If you have any questions, please write your answers in the please ask me. Please write your doubts in the chat box, or you can ask me directly. Okay, let's see question number 2. Emission of one alpha particle results in shift in how many places in the periodic table? Emission of one alpha particle results in shift in how many places in the periodic table? Option A, 2 places towards right. Option B, 4 places towards right. Option C, 2 places towards left. And option D, 4 places towards right. What would be the correct answer here? Okay, I see already some people have answered. I request others also to write your answers in the chat box. 4 of you are saying option C, two places towards left. Anyone else wants to give the answer? No one? So option C, 2 places towards left, is the correct answer. So first we'll understand what an alpha particle is. So alpha particle is similar to a helium nuclei. Okay, so you know helium has 2 protons and 2 neutrons. So the mass number is 4 and the atomic number is 2. Whenever we write an atomic symbol, we denote the mass number on the top and atomic number at the bottom. So atomic number is equivalent to the number of protons, whereas mass number is equivalent to number of neutrons plus protons. Okay, and alpha particle is similar to a helium nuclei, so it has 2 protons and 4 neutrons plus protons. Okay, so now if we have some element, so now you know that in a periodic table the elements are arranged in the order of atomic number, right? So in the periodic table you have hydrogen, which has atomic number 1, then helium, which has atomic number 2, and so on. So it is always arranged in the order of atomic number, right? Okay, increasing order of atomic number. Now if I have some arbitrary element X whose atomic number is A and mass number is M, okay, and from this alpha particle, that is this helium nuclei, is emitting out. That means this will be coming out of this alpha particle. Alpha particle would be coming out of this imaginary element, right? So what will happen? We'll have one alpha particle out of this, and what will be remaining? Remaining would be a new compound, let's say Y, new element, that let's say Y, whose atomic number would be whose atomic number would be A minus 2, and the mass number would be M minus 4. Why? Because 2 protons have left this element, 2 protons are released from this element in the form of alpha particle, and the mass number is also reduced by 4. Okay, so now what will happen? The new atomic number is 2 less than the older atomic number. That means it will shift towards the left side of the periodic table because the atomic number is decreasing. So it will move towards the left side of the periodic table. Okay, and how many places towards left? 2 places towards left. Okay, I hope this is clear to everybody. Anyone has any doubt in this? Especially people who haven't answered in the chat box. Do you have any question or do you have any doubt in this? Do you understand what alpha particles are?
Yes, ma'am.
Great. So the correct answer is option C that we discussed. Okay, this is just an example of uh, alpha emission, where you can see the atomic number is lowered by 2 and mass number is lowered by 4. Okay, moving on to the next question. 70% of a radioactive sample is left undecayed after time t has elapsed. What is the approximate percentage of the initial sample that will decay in total time 2t? So 70% of the radioactive sample is left undecayed after time t has elapsed. That means 30% has decayed, 70% is left after time t. So what would be the percentage of the initial sample that will decay in total time 2t? So this is a numerical question. I will give you all some time to solve this question. Once you solve the question, write your answers in the chat box. Anyone knows how to solve it? Try to solve the question. Okay, I already have one answer in the chat box. Very good. Option B, 51%. Okay, we'll see if that is the correct answer or not. Okay, now 2 people are agreeing to option B. So for people who are not able to solve, I'll tell you what formula to be used. So the radioactivity is defined by this equation, where n is the amount of sample that is remaining, n0 is the initial amount of sample, e is the exponential term, e raised to the power of minus lambda t. Lambda is the decay constant and t is the time. So now you can see in this question what is given. In this question we have at time t 70% is left. That means we have the information about n. 70% of the initial is left. So 70% means 70 by 100 of the initial sample is left. This will be equal to the initial sample n0 e raised to the power of minus lambda and time is t. Okay. So this would be your first equation. From this, what you can derive? You can derive the value of lambda in terms of t. So n0 will get cancelled by n0. You can write it as 7 by 10. So this will be, when you solve this bracket, this will be e raised to the power of lambda t is equal to 10 by 7. I remove this negative sign, so this will be reciprocal, and then this can be written as lambda would be equal to 1 by t natural log of 10 by 7. So this is the value of lambda that we'll get from the first equation. Okay. Now you have to tell the approximate percentage of the initial sample that will be remaining after time 2t. So now the new equation would be, now x percent, let's say approximate percent, your final answer is x. Okay, so x by 100, n0 would be equal to n0 e raised to the power of, now lambda's value we know, so lambda would be negative of 1 by t natural log of 10 by 7 into 2t, right? 2t, because instead of t now the time is 2t. Okay, so the t will get cancelled by the t, n0 will get cancelled by n0, and you will have, if you solve this further, you will get e raised to the power of negative 2 multiplied by log of 10 by 7 is equal to x by 100, then you take the reciprocal, so 100 by x, then your negative sign will go, and then you take log, so it log on both sides, so this will be log of log would be cancelled out, so this will be 10 raised to 10 by 7 raised to the power of 2, because this power will go on that side. So I hope everyone is familiar with solving exponential equation. Otherwise, what you can do is you can use your calculator and directly solve this. Just take 10 by 7, the value of natural log, multiplied by 2, and then take the whole thing in the power of e. If you can do that, whichever form you are comfortable with, do that and solve for x. When you multiply it by 100, you will get the value of x. Let's see the correct answer. So I see most of you have answered option B. So let's see, option B is the correct answer, 51%. So all of you have solved it correctly. People who haven't solved it or who were not able to solve it, I hope this is clear now. I hope you understand how to solve it now. If this explanation seems too much to you, you can simply use your calculator and calculate. Whichever way you find it easier to calculate, you can do it. Okay. I have added this solution because this was simpler for me. Is this clear to everyone?
Yes, ma'am, clear.
Okay. People who haven't answered, I hope it is clear to you. If you have any form of doubt, please ask me, okay? Moving on to the next question now, question number 4. By how much the average life is greater than the half-life? By how much the average life is greater than the half-life? Options are A 1.44 times, B 2.54 times, C 1.21 times, and D 3.54 times. By how much the average life is greater than the half-life? So average life basically means the mean time or the average time taken by a sample to decay completely, and half-life means the time taken by the sample for to decay 50% of the initial sample. So half-life is basically the time at which half of the initial sample has decayed. This is, we are talking about radioactive decay, and average life is the total average time that a sample takes to decay completely. So naturally average life would be greater than the half-life, but by what ratio? I see already a lot of you have answered option A. Yeah. So all of you have answered option A. Let's see if that is the correct answer or not. Option A, 1.44 times. That is the correct answer. So how do we solve it? So this is the formula for average life. Average life is defined as the reciprocal of the decay constant. Okay. So average life or the mean life, it is the reciprocal of the decay constant. Now you are familiar with this formula. We have already used it in the previous question. N is equal to n0 e raised to the power of minus lambda t. Okay. Now if you talk about half-life, I told you half-life means the time taken for the sample to decay 50% of the original amount. So now n would be n0 by 2 because half of the initial sample has decayed, and n0 by 2 would be equal to n0 e raised to the power of minus lambda into t. This time t would be t half, that is the half-life, half-life of the sample. Okay, so from this this n0 will get cancelled out with n0, and if you solve this further, you will get t half is equal to natural log of 2 by lambda, and the value of natural log of 2 is 0.693. So t half would be equal to 0.693 by lambda, or lambda would be equal to 0.693 by t half. This is a very important equation. In most of the question, you will be using this equation. Either the t half will be given or the decay constant will be given, and you will have to find the other one. So this, you should always remember that t half is equal to 0.693 by lambda, or lambda is equal to 0.693 by t half. Okay, now lambda is equal to 0.693 by t half. I told you average life was 1 by lambda, so this will be t half by 0.693. So if you take 1 divided by 0.693, the value is 1.44. So average life is 1.44 times greater than t half, that is the half life. Okay, so half life is the time for the half of the nuclei to decay. Average life is the average lifespan of a single radioactive nucleus before it decays. Okay. Is this clear to everyone?
Yes, ma'am.
Okay, the next question, question number 5. An instrument used for the measurement of radioactivity is. Options are UV-Vis spectrophotometer, mass spectrometer, Geiger-Müller counter, and nuclear reactor. An instrument that is used for measuring the radioactivity. Option A, UV visible spectrophotometer. Option B, mass spectrometer. Option C, Geiger-Müller counter. And option D, nuclear reactor. What would be the correct answer? Write your answers in the chat box quickly. I already see many answers in the chat box, which are option C, Geiger-Müller counter. What about others? Anyone else wants to write the answer? Okay, the correct answer is option C. So all of you are correct. Geiger-Müller counter, it is an instrument that is used for measuring the radioactivity. So it has a gas chamber, and then if there is radioactivity present in an place, if we use this instrument, the radioactivity will basically ionize the gas and then accelerate the electrons which are connected to a circuit, which will amplify the current, and eventually you will get a beep sound out of it. So I don't know if you have seen any documentary or any news about this, but these are instruments which are very sensitive instruments which are used to measure radioactivity. So if there is let's say an accident that has happened where radioactivity where like the region has become radioactive, to check what all areas have the radiations present, this instrument is used, and it gives a beep sound wherever the high radiation or high radioactivity is present. So that's how we detect the radiation. Okay. Okay, next question is, which of the following series denoted by 4n plus 3? Which of the following series is denoted by 4n plus 3? Options are actinium, option B thorium, option C uranium, and option D none of these. Which of the following series is denoted by 4n plus 3? Write your answers in the chat box. Okay, I see most all of you are answering option A, actinium. Uh, so actinium series is denoted by 4n plus 3. You are correct. So these are decay series. So we have thorium series, uranium series, actinium series. So these are denoted by formula 4n, 4n plus 1, 4n plus 2, and 4n plus 3. Neptunian series is almost extinct, so we don't really study this anymore. Thorium, uranium, and actinium series are being studied. So this basically represents that the thorium series, the mass number, uh, sorry, the thorium series, uh, the mass number, the parent nucleus basically has the number which is an integer of 4, which is a multiple of 4. So if you take any, if you replace the value of n with any whole number, you will get, like here the example thorium, which is the parent nucleus, the number is 232. If you divide it by 4, you will get a whole number. Whereas for uranium, you have 4n plus 2, because if you divide 238 by 4, you will get uh, so 59. So the value of n would be 59, and then so 59 into 4 plus 2 would be your 238. And then actinium series, it is uranium 235. The parent nucleus is uranium 235. Once it decays, you get, eventually you get the actinium uh, atom, which is AC, actinium nucleus. And all of these, when they decay, the end product is mostly lead. Okay, some stable isotopic form of lead. So lead is the most stable product. These nucleus are more prone to undergo decay. Okay, I hope that's clear to everyone. Moving on to the next
Ma'am,
question.
can you show question number
Yeah,
6 once again?
sorry.
Ma'am, can you show question number 6 once again? Just the question.
Question. Yeah, this was the question. Which of the following series is denoted by 4n plus 3? The answer is actinium. Thorium is denoted by 4n. Uranium is denoted by 4n plus 2. Okay.
Thank you, ma'am.
Yeah. Okay. Question number 7. The half-life of a radioactive isotope N is 35 years. It decays into another element Y, which is stable. The two elements N and Y were found to be in the ratio 1:7 in sample of given rock. The age of the rock is estimated to be. Options are 200 years, 105 years, 150 years, and 85 years. Again, this is a numerical type question. Use the formula that we have discussed. N is equal to n0 e raised to the power of minus lambda t. Half-life is given as 35 years. The ratio of n and y is given as 1:7. So from that you can find out n and n0. Lambda, you can find it out from the half-life, and time is what you have to estimate. So do the calculation quickly and let me know the answer. I already have one answer in the chat box. So T half is given as 35 years, right? So lambda would be 0.693 by T half, that is so you will get the lambda from here. Now n is to y is given as 1 is to 7. The ratio is given as 1 is to 7. So what would be the initial both n and, so let's say n is decaying into y, that is what it says, right? It decays into another element y. So initially everything was n, so the total n0, the initial amount of n would be 1 plus 7, because the seventh part of y would also be part of n, so n0 would be 8 and n is 1 now. So n is equal to n0 e raised to the power of minus lambda t. T is what we have to find. N is 1, n0 is 8, e raised to the power of minus lambda would be this value. Solve this and t is what you have to find out. Okay. I can see some of you have solved this question and you are saying it is option B, 105 years. Anyone else wants to answer? Okay. Let's see the correct answer. It is option B, that is 105 years. So I told you how to solve this. So lambda would be 0.693 by 35. You solve this, you will get 0.0198 year inverse. And then you just replace the values in the formula. So n0 would be 8, n would be 1. So n by n0 is 1 by 8. This is equal to e raised to the power of minus lambda into t. So e raised to the power lambda t would be 8 by 1 or 8. If you take log both sides, you will get 0.0198 t is equal to natural log of 8. Now take the value of natural log of 8 divided by 0.0198, you will get the answer approximately 105 years. I hope this is how you all have solved this. And people who haven't answered, I hope this solution is clear to you now. If anybody has any doubt in the question or in the solution, please ask.
No, ma'am.
Okay, moving on to the next question then. Question number 8. Uranium ore contains 10.2 grams of U-238 and 9.2 grams of Pb-207. Calculate the approximate age of the ore given molecular weight of uranium and lead are 238 and 207 respectively. Half-life of uranium is 4.5 into 10 raised per 9 years. So you have the weight of uranium and lead. You have to calculate the approximate age of the ore. And half-life is given. So half-life is given. First you can calculate the decay constant and then use the formula to calculate the age of the ore. All of you solve this and then we'll discuss the solution. one thing you have to take care here is you have to consider the moles of the uranium and lead, because the molecular weight is given, the given and the actual amount is given, so you can calculate the mole by dividing the given weight by the molecular weight, and the N and N0 would be in terms of the moles, not the actual weight. Okay, now use the given information and calculate. I already have one answer. Very good. Option B you are saying, Malini. Option B 4.6. Okay. What about others? This is very similar to the previous question. You have both uranium and lead, number of moles of uranium and number of moles of lead. So consider that all the lead was once uranium, so you will have the N0, that would be number of moles of uranium plus number of moles of lead, and the current N would be the number of moles of uranium. Your half-life of uranium is already given, so you can calculate the decay constant. So lambda will be lambda can be easily calculated. Only thing that you have to calculate is T. So we have half-life given. So from this, first calculate the lambda. Lambda would be 0.693 by 4.5 into 10 raised to the power of 9. Okay, solve this first, and then what would be the moles of uranium? Moles of uranium would be 10.2 divided by 238, and moles of lead would be 9.2 divided by 207. So once you have these, your N0 would be moles of U plus moles of Pb. Okay, and N would be moles of U, and then you can replace the value. N is equal to N0 e raised to the power of minus lambda T. So lambda you have, N you have, N0 you have to calculate for T. Only two people are able to solve this. We just solved this question similar to this question, right? Where the ratio is 1:7, the previous question, it's the same thing. Now instead of those ratios, you have more decimal numbers, so I understand that the calculation might be little complicated, but try to do it. Okay, 3 of you were able to solve it. Okay, now, so I see all of you who have solved it, you are saying option B, right? 4 people have answered till now, and you are getting option B. So I hope all of you are going in the right direction. I have already told you how to calculate it, so let's see option B is the correct answer or not. 4.6 into 10 raised power of 9, that is the correct answer. So see, this is how you have to solve. The lambda is 0.693 by T half. So T half was 4.5 into 10 raised power of 9. If you divide it, you will get the lambda, that is the decay constant. Now 10.2 grams of uranium would be equal to 0.043 moles, and 9.2 grams of lead would be 0.044 moles of lead. Now the initial would be So all of the lead was once uranium. So the total initial would be the total of uranium moles and lead moles. So 0.043 plus 0.044. That gives you the total of 0.087 moles. That is the N0. N is 0.043. Okay. So just solve it. So you have N is equal to N0 e raised to the power of minus lambda T. N is your 0.043. N0 is 0.087. E raised to the power of lambda is 0.154 into 10 raised to the power of minus 9 multiplied by T. Okay. So you can easily solve it. So this will be 0.087 divided by 0.043. Take natural log of this. This will be equal to 0.154 into 10 raised to the power of minus 9 into T. Now you can solve it. Whatever would be the value of this natural log, divide that with 0.154 into 10 raised to the power of minus 9, and you will get the answer to be 4.6 into 10 raised to the power of 9. I hope all of you are able to solve this. I see for this question less people have answered, so I hope people who haven't answered, this is clear to you. Anybody has any question? Any doubt in this calculation? Any form of doubt you can ask. Feel free to ask. Like even if you have difficulty in understanding these logarithmic equations, you can ask. I can explain. I hope all of you are familiar with the natural logs and all.
Yes, ma'am. No doubt.
If anyone has any doubt, you can write it in the chat box or you can ask. Okay. I'll move on to the next question. Question number 9. The decay constant of a radioactive element is 0.0223 day inverse. Find the half-life. So lambda is given, you have to calculate the half-life. So this is very straightforward question. All of you should be quickly solving this. What is the relation between lambda and half-life? We have been using that formula everywhere, so you should be able to answer this quickly. I want answers from everybody for this question. We have been discussing this for the past 3 or 4 questions. So all of you by now, all of you should know what is the relation between the decay constant and half-life. Decay constant is lambda. Lambda and half-life has a relation. We have been using it in the all the previous questions. You don't even have to write anything for this question. Just use your calculator and quickly tell me the answer. If the d lambda is 0.0223, what would be T half? Okay. I see many of you have answered option C. So I hope now everybody is understanding. So decay constant, I told you it is lambda. So lambda is equal to 0.0223 and T half is equal to 0.693 by lambda. Okay, so this relation you have to remember because all of the questions will use this. So T half can be easily solved. Just divide 0.693 by 0.0223. So you'll get 31 point something. So 31 days, approximately 31 days is the half-life of this element. I hope this is clear to everyone. I can see most of you have answered option C. So 31 days is the correct answer. If anyone has any doubt, please ask. Meanwhile, I'll move to the next question, question number 10. The C14 to C12 ratio in a piece of wood is 16% that of the atmosphere. Calculate the approximate age of the wood. So C14 to C12 ratio, C14 is an isotope of C12. So the ratio of C14 to C12, it is given as 16% that of the atmosphere. What is the approximate age of the wood? And T half of C14 is given as 5580 years. So again, T half is given, the ratio is given. So from the ratio, you can have the idea about N and N0. T half is given, so you can solve for lambda. And you have to calculate the value of T. So similar to the previous questions, quickly all of you do the calculations and tell me the answer. All of you write the answers in the chat box. I can see 2 people have answered option B. What about others? So half-life is given as 5580 years. So lambda would be 0.693 by 5580 years inverse. Okay, so solve this and then your, yes, anybody has any question?
No, ma'am. The lambda value will be 1.24 into 10 to the power minus 4.
So this is 1.24 into 10 raised to the power of minus 4. Okay, then you have, so it says C14 to C12 ratio is 16%. So that means your N to N0 ratio would be 16%, right? So from that you can find out N and N0. You have the lambda. All you have to find is the value of T. Okay. So I see all of you are answering option B. Let's see if that is the correct answer or not. Option B is 14,758 years. That is the correct answer. So you said lambda value is 1.24 into 10 raised to the power minus 4. That is correct. So your N0 by N. So N is 16% of N0. So N0 by N would be 100 by 16. Okay. This is similar to the one of the previous question where we had this percentage problem. So this would be 16% of N0, and we have N0 e raised to the power of minus lambda T. So your lambda T would be equal to 100 by 16 natural log. Okay. So that is what we have taken. So lambda value is here. So just divide 100 by 16 and then take a natural log of it, then divide 1.242 from that and you will get the answer. I hope the solution is clear to everybody. If anyone has any doubt, please ask. Okay.
Ma'am, in this
Yeah.
question, the ratio between the 14 isotope of carbon and the C12 carbon, the ratio is 16%. So means the amount of percentage is 16%. So ma'am, we can write the ratio as 16 by 100. So the ratio between them is 4 by 25. So the N naught value can be 4 plus 25, that is 29, and the N value, that is the 14th carbon, so it will be 4. Can it be like that?
Yes, you can do it like you solved it like that.
Uh, yes, ma'am.
Yeah, and
But
you
ma'am, the
got
value for it came like 1.5975 into 10 to the power of 4, which means 15975 years.
okay. Wait, what did you do exactly? So you are saying it is 16 by 100. You simplified it to 4 by 25.
4 by 25.
Okay, and then you considered
Yes, ma'am.
the ratio. Okay, so the
The
mistake
N
that
naught value as
no, no,
4
no.
plus 25.
I'll tell you what mistake you have made here. So n is basically 16% of the initial value. Okay, so if initial is 100, that means n is 16. Okay, do you understand? If
Okay.
initial is 100, then from that 100, the n is 16. Like 16% of 100 would be 16, right? In this case, what you are considering when you are taking 16 by 100, this is n by n0. Okay, this is not that ratio.
Yes,
So
ma'am.
the ratio that you are talking about, that was some, let's say n was going to m. So the ratio of n and m, if it is given, then you can take that addition, like you can add these two to get the value of n0. But here the n0 is already clear that n0 is 100. That's why we are taking n as 16. Okay, so if you simplify, you have to consider n as 25. Sorry, n0 as 25 and n as 4. Do you understand the mistake that you are
Okay.
making?
Okay.
Okay, you can't take the addition in this case. That ratio that we are talking about, that ratio is for two different elements, like one radioactive element decaying into another element. So we are talking about the ratios of those two. But here this ratio is about the initial uh, amount and the final amount. So that ratio, final is to initial ratio, we are talking about. We are not talking about the amount that has decayed into some other form. So in this case, if you wanted to talk about the ratio, it would be 100 minus 16, that is 84, right? So 84 would be your another element m. So if I would have given the question in this way, like the ratio between two elements are 16 is to 84, then you can take 16 plus 84, that is 100 as n0, and 16 as the initial. Okay.
Okay, ma'am.
Yeah. I hope this is clear to others also. I hope you understood the doubt she asked and what we like what she was doing, because I can understand that you might have applied the same logic that we used in the previous question, but you have to understand the difference between the previous and this question. I hope all of you understood this. Good thing that she asked this, so that this you should not get confused between those two cases.
Ma'am, but here two different isotopes of carbon are taken.
Yeah, but I never said that. See, this is 16% of the initial. Sorry. Wait. So here we are not talking about the amount of C12 and amount of C14 individually. We have said C14 to C12 ratio in a piece of wood is 16% of that of atmosphere. So whatever C12, whatever the initial, from that we are taking the 16% of the initial, as C14, and the half-life of C14 is given. So you have to use the amount of C14 and the decay constant of C14. Is this clear?
So, ma'am, here it means that C14 by C12, which is equals to 16%. So, it will be C14 of 16%, means C14 is equals to 16% of C12 in that form.
No. In this, it means that C14 is 16% of the initial amount that was there. So, initially, all of the like imagine all of the carbon was in form of C14. Okay, and from that 16% is now remaining as C14, rest of it has become C12. Okay.
Okay, ma'am.
Yeah.
Okay, ma'am. Thank you.
Yeah. Is this clear to you as well? Who asked the question? Mopia, I
Yes,
think.
ma'am.
Huh. Is it clear to you? No? Okay. I can move on to the next question, or anyone has any other doubt?
No, ma'am, no doubt.
Okay, moving on to the next question. Question number 11. Identify the type of emission in the following reaction. So you can see one reaction is given where lead is decaying into bismuth, and we have the mass number and atomic number given for both the elements. So you have to identify the type of emission that is happening in this reaction. Options are alpha emission, alpha emission followed by beta emission, or beta emission followed by alpha emission. So what would be the right answer here? I can already see 3 people have answered. What about others? What type of emission is happening in this reaction? Okay, I see all of you are answering option B, that is beta emission. That is the correct answer. So I've already talked about alpha emission. So alpha emission refers to emission of alpha particles. And what was alpha particle? Alpha particle was helium nuclei. So if there was an alpha emission, what would happen? The atomic number will reduce by 2. So atomic number would have become 80, and the mass number would have reduced by 4, that is 206. Okay. Now in this case, what is happening? The mass number remains unchanged, only the atomic number is changing. Now I've told you the atomic number is equal to the number of protons, and the mass number is equal to the number of protons plus neutrons. Okay. Now what happens in beta emission? In beta emission, what happens? One of the neutrons, it gets converted into proton. So what happens if we have, let's say, 5 protons and 5 neutrons? Okay. So this is P, this is N. If we have 5 proton and 5 neutron, and one of the neutron gets converted into proton, so what will happen? The final number of proton would be 6, final number of neutron would be 4. Now the mass number is the addition of 2. So mass number initially was 10, mass number finally would also be 10, because one neutron is getting converted into proton. So the total will always remain same. So the mass number will remain same. The only thing that will change is the number of protons. So if the number of proton increases by 1, what will change? Atomic number will increase by 1. So that is what is happening here. Atomic number is increasing by 1, that is 82 becomes 83, and mass number remains same. So one of the neutron has gotten converted into proton. So that is the beta emission. In beta emission, only electron or positron is released. Okay, so depending on conversion of neutron into proton or proton into neutron, a electron or positron is released from the element. Okay, alpha emission, we will have reduction of both atomic number and mass number. Okay, so now if some other reaction is given, you can find out. There can be cases where one alpha emission is happening followed by beta emission. So in that case, first you will have reduction of 2 atomic number and 4 mass number, and then you will have another reduction or addition of atomic number, and there will be no change in the mass number further. So that's how you have to find out what kind of emissions are happening. Okay, most of you did answer option B, beta emission, so I hope this is clear to you. Anybody has any doubt in this?
No, ma'am, no doubt.
Okay, the next question is, after which atomic number value all nuclei become unstable? What is the atomic number after which all nuclei become unstable? Options are option A 20, option B 43, option C 63, and option D 83. After which atomic number value all nuclei become unstable? I can see 4 answers in the chat box. All of them are option D 83. What about others? Quickly write the answer. This is a theoretical question. Okay, most of you are answering option D, so that is the correct answer. So after atomic number 83, all the nuclei become unstable. Why? The reason is actually demonstrated by this plot. So initially the number of protons and the number of neutrons are almost equal. Okay, and that's why you will see for smaller nuclei, for the atoms present at the initial part of the periodic table, you will see the mass number is generally double of the atomic number. If the atomic number is 1 for hydrogen, let's say, the mass number is 2. For helium, atomic number is 2, mass number is 4, because the number of neutrons and protons are equal in most of the cases and for smaller nuclei. But as we go on, as we move towards the left side of the periodic table, as we move ahead of the periodic table, what happens? The ratio slightly starts deviating, where the number of neutrons becomes higher, number of neutron to proton ratio becomes higher. That means more proton is present than the number of neutrons. And what happens because of this? Excessive proton-proton repulsion starts happening. Now, if 3 neutrons and 3 protons are present, then the charge will be balanced. But if the number of protons are very high, like let's say 30 protons are present and only 20 neutrons are present, then the number of protons will be very high, and because of that high number, protons are positively charged. So, and you know that like charges repel each other, so positive will have repulsion, and excessive proton repulsion will make the nuclei unstable, and it will start undergoing decay. And that's why we have all these alpha emission, beta emission, because in such emissions, what is happening ultimately? The nucleus is breaking down into smaller nuclei, right? So if alpha emission is happening, one helium nuclei is coming out of it. So the nuclei, the number of protons and neutrons are ultimately decreasing, and it will keep on breaking down into smaller nuclei till it achieves a stable isotopic form, where the nucleus is stable enough to have the protons and neutrons in it. Okay, so high neutron to proton ratio disrupts the stability. Is this clear to everyone?
Yes, ma'am.
anyone, if you have any doubt, you can ask. Otherwise, I'll move to the next question, question number 13. What is the approximate rate of disintegration of 0.004 grams of a sample of radium whose mass number is 226 if the T half is given as 1350 years? So you have to find the rate of disintegration. So you have the mass given, you have the mass number given, you have the T half given. First of all, from the T half, what we can find? From the T half itself, we can find the decay constant
Lambda.
Yes. So calculate that, and then you have to calculate the atoms, number of atoms that are decaying per minute. So the unit of decay constant is time inverse. Okay. Now you have to make sure that you convert this in minutes because your options are given in minutes. So you have the T half given in years. So first convert it in minutes and find out lambda in terms of minute inverse, and then you have to find the number of atoms in this much gram of radium. Okay. I'll give you some time to solve it and then I'll help you out. No one is able to solve it? Okay, I hope you have. Yeah, okay. Solve. So the rate of disintegration is given as dN by dt, negative of dN by dt, that is the rate by which the nucleus is decaying in time t, and this is denoted by lambda into n. So you have to find the number of atoms in this much gram of radium and then multiply it with decay constant. Okay, I see 3 answers in the chat box. Option B. Okay, what about others? So 0.004 grams means 0.004 divided by 226 moles into the Avogadro number, that is 6.023 into 10 raised to the power of 23. This would be the number of atoms. This multiplied by lambda would give you the rate of disintegration. Okay, I hope people who have solved it has done it in this way only. I see more people are now answering option B, so good. Anyone else wants to write the answer or should I show the solution? Okay, great. Many of you have answered option B, 10.8 into 10 raised to the power of 9. That is the correct answer. So T half, I told you the T half is given in terms of years. So 1350 years multiplied by 365 days into 24 hours into 60 minutes and 1 hour. So this would, you have to solve this and divide it by 0.693. So you will get the decay constant as 9.8 into 10 raised power of minus 10. Now 1 mole would be 0.04 into 0.004 divided by 226. This would be 1 mole of radium multiplied by the Avogadro number would give you the number of atoms. So number of atoms present in 0.004 grams of radium would be 1.1 into 10 raised power of 19. Now you have to, all you have to find is the number of atoms per minute. So you have decay constant, you have the number of atoms, just multiply it and you will get the answer. I hope this is clear to everybody. It's not very complicated, it's just that you have to do some calculations. These questions do require the use of calculator a lot, and I would request all of you to practice such type of questions so that you are well in time when you're writing an exam. Okay, if anyone has any doubt, please ask, write it in the chat box or ask whatever you feel comfortable, especially people who haven't answered. I hope this is clear to you. Moving on to the next question, question number 14. What is meant by nuclear transmutation? What is meant by nuclear transmutation? Options are option A, transformation of one nucleus into another. Option B, splitting up of one nucleus into two parts. Option C, combination of two nuclei to form a new nucleus. And option D, none of the above. What is meant by nuclear transmutation? Okay, I already see a lot of answers. All of them are option A, transformation of one nucleus into another. Five people have answered. What about others? Anyone else wants to write the answer? What is meant by nuclear transmutation? Okay. Okay. 5 of you have answered option A. You are correct. It means transformation from one nucleus into another. So the word mutation itself, if you are familiar with the biology term mutation, molecular biology term mutation, you know that it means change. So we generally talk about mutations in our DNA, which means change in the nucleotide. So mutation is generally used for change or transformation. So nuclear transmutation, by the name itself you can understand, it is transformation of one nucleus into another. Splitting up of one nucleus into two parts, it's actually called fission. So this is called fission reaction. Okay, and combination of two nuclei to form a nucleus, what is it called?
Fusion.
Yes. So fission and fusion reaction you might have studied in your class 12th exams during the radioactivity chapter. So these are fission and fusion reactions. So all the alpha emissions that we are talking about, where the nucleus is splitting into two different nuclei, that is basically a fission reaction. Similarly, fusion reactions also happen where two nuclei combine to form a new nucleus. Okay. I hope this is clear to everybody. Nuclear transmutation is transformation of one nucleus into another. Moving on to the next question. If the radioactivity of a radioactive element gets reduced to 1 by 128 of its initial value in 20 days, then what is the half-life? So you have to calculate the half-life. You have the T, 20 days. You have the initial and the final value given in the form of ratio. So the final is 1 by 128 times of the initial value. Okay. So what you can get from this, you can solve for lambda first and then you can calculate the half-life. So we have this formula, the golden formula that we have been using. N is equal to N0, E is equal to minus lambda T. From this, you first calculate for lambda and then you calculate for the half-life. I'll give you some time to do the calculation and then we'll discuss. Write your answers in the chat box. Okay. I already see one answer. Very good. Okay, 3 people have answered. I'll wait for others to answer as well. So N is given as 1 by 128 of its initial value. So if initial is N0, N would be 1 by 128 times of N0. This will be equal to N0 e raised to the power of minus lambda, and T is 20, right? So N0 will get cancelled out and you will have e raised to the power of lambda into 20 is equal to 128. Now take log on both sides. You will get lambda is equal to 1 by 20 natural log of 128. Once you find lambda, you can find T half 0.693 by
lambda is 0.2426.
Okay, lambda is 0.2426.
2426. Yes, ma'am.
So this will be 0.2426 day inverse, and then from that you can find T half. T half would be 0.693 by lambda. So that is coming as 2.89 days. That is all of you who have answered have given option D as the correct answer. So very good. You're getting approximately 2.856. That is fine. I think you might have taken the decimal places more or less, then your answer might differ a bit. I hope the options, yeah, the options were very fast. So generally in the competitive exams also, if such questions are there, like if the answer is 2.89 and if you have to write the answer, like for exams like GATE and all, you even if you write 2.88 or 2. Like if it is in the range of 2.8, they do accept the answer. So they have the answer key also. In that answer key also they have the answer in a range instead of one final answer. So it's fine. Anyone has any question or any doubt in this? Please ask if you have any doubt in the calculation. All the questions are pretty similar, so I hope it's clear to everybody. Still, if you have any form of doubt, please ask. This session is for that only. so that you ask questions and I can clarify your doubt. So if you don't understand any point, please get it clear. So here the language was more clearer, so you can understand that the final amount is 1 by 128 times of the initial value. In that question, I can also understand the language was not that clear. So you will have to, once you keep on solving such type of questions, you will get the idea of what to take as the value of n0 and what to take as the value of n. Okay, I think I can move on to the next question then, if there are no questions. Question number 16. If half-life of radon is 3.8 days, then approximately how much radon out of 40 gram will be left after 17 days? So you have the half-life. Now you have to tell the amount of radon that would be left out of 40 grams. So 40 gram is the initial, okay, and time is given as 17 days. So you have to basically find the value of n. Time is given, n0 is given, t lambda can be calculated from the t half. So you just have to find the value of n. So quickly do the calculation. Tell me the answer. Okay, I see one answer in the chat box. All of you do the calculation quickly.
Ma'am,
Yeah,
ma'am, I'm Mohboni.
yeah.
May I ask you a doubt regarding the question number 13?
13.
Yes, ma'am.
Yeah, tell me.
Actually, my answer was approximately 10.39 and the actual answer is 10.8. So, is there any problem, ma'am?
10.39. Or maybe you have taken the decimal places. So I have taken till single decimal places. So maybe that's why there is a difference. I hope you have followed this like similar calculation scheme, or you have done something else. Can you tell me?
I'm a little bit.
So you also got a similar product here, right? 9, like instead of 9.8, was it like 9.7 something something and 1.06 something something like that you had, and then, or you did something totally different? Because I don't think that much variation should be there. Also, another thing I would suggest all of you, like if the options are given in single decimal place, I would request all of you to start taking the, like start shortening your ratios from the beginning to single decimal place. Or if the options are given in double decimal place, start shortening the answer to double decimal place from the beginning itself. Like here also, see, the options were
I'm
given
okay.
in double decimal place, so I have taken the lambda value to double decimal place only, so that would make you get the answer more closer to the options, because in such cases, because of the fourth or fifth decimal place also, your answer might differ in the decimal places. So that's why you can take care of that. Rest you can check the
Okay,
calculation
ma'am.
once. I will upload the slides, so then you can do the calculation once again and check. I hope, like if you have done the same thing, and you are getting a different decimal place value, it might be due to the calculation, like you have taken the decimal place up to 5, up to 5 decimal places or 6 decimal places, then in that case it might differ. Okay.
Okay, ma'am. After doing your process, I have this answer.
Okay, what process did you follow? If you can tell me, then I maybe if you are doing something wrong, I can tell you. How did you calculate, if you can tell me? Mobani?
Yes, ma'am.
How did you calculate earlier?
First of all, I have done T half. Ma'am,
T half
just
was
a
given.
minute.
T half was
Ma'am,
given.
just
So
a minute.
yes, yes, yes. Okay.
Yes, ma'am.
Hmm.
Yes, T half 1350 years, and then um, I multiplied 365 days by 1 year
Hmm.
into 24 hours by 1 day
Hmm.
into 60 minutes by 1 hour
Hmm.
and into 60 seconds by 1 minute. And my T half was
Okay,
4.256 into
you don't
24
have
times 50.
to take it to seconds, because your answer is given in minutes form, right? So that's what I was telling you. You will unnecessarily increase your calculation process, right? So you have to check what unit is your answers given. Especially when you're solving a multiple choice question, you have to make sure that you are checking the units of the options first. So the unit of the question was years, and in the options it is in minutes. So you just convert it till minute. So 1350 into 365 into 24 into 60. Stop there. Okay. Then what? Okay.
Okay, ma'am.
After
Okay,
that,
ma'am.
what you did, once you get the lambda, then you got the lambda in second, then again you
Yes, ma'am.
divided it
Lambda
by
in seven.
60.
Yeah, ma'am.
Hmm. So you got
Then
it in minutes.
n equal to our mass by molar mass, and mass was given 0.004 gram,
Huh?
and molar mass 226
Yes,
gram per mole.
yes,
And my answer was 1.7699
yes.
into 10 to the power minus 5 mole.
Okay. And then you multiplied it by,
Then yes, ma'am. Then I have multiplied it with Avogadro number.
yes.
Avogadro number is 6.022 into 10 to the power
Huh.
23. And my answer was 1.065 into 10 to the power 19 atoms.
So
The number of
that
atoms
is
was,
approximately 1.1. So that's what I said. You might have gotten something 1.06 something
yes,
into
ma'am.
10 to
Yes,
the power
ma'am.
19. So that
Yes,
multiplied by
ma'am.
your time in minute. So that would be times, not time, decay constant in minute inverse. So that would be your
A
time.
equal to lambda n.
Huh.
Yes.
Okay.
Yes.
Okay.
Thank you, ma'am.
Yeah. Okay. So where were we? We were discussing question number 16, right?
Yes, ma'am.
Yes, ma'am.
So I see 3 of you have answered option A. Let's see how to solve this. So we have the half-life given as 3.8 days. So from half-life, we can get lambda. Okay, so lambda would be 0.693 by 3.8. Now you have to find n. Your n0 is 40, e raised to the power of minus lambda. Lambda you can solve from here into 17 days. So now you once saw, this is very direct. So you just have to solve it, use your calculators and do the calculation. Okay.
Ma'am, lambda is 0.1824.
Okay. Lambda is 0.1824 multiplied by 17. then take the negative of that and power of E, you will, I think, get something 0.04 or 0.05, and then multiplied by 40, you will get 1.8. That is the final answer. Okay. I hope this is clear to everybody.
Yes, ma'am.
Anyone has any doubt, please ask. If there's no doubt, then I'll move to the next question. In all the radioactive decay, which one is the ultimate stable product? We have already discussed this, so all of you write your answers in the chat box. In all the radioactive decay, which one is the ultimate stable product? Options are thorium, lead, uranium, actinium. All of you are answering option B, lead. That is the correct answer. We have already discussed when I told you about the decay series of thorium, uranium and actinium, 4n, 4n plus 2 and 4n plus 3. So all of these radioactive element, they keep on decaying until it reaches the ultimate stable product, that is lead. Lead nucleus is the most stable, so it forms the lead isotope. Okay. Sorry. Okay, moving on to the next question. Which of the following is a radioisotope? Options are option A, carbon 12, option B, phosphorus 32, option C, sodium 23, and option D, sulfur 32. Which of the following is a radioisotope? Write your answers in the chat box. Think of the atomic mass that we generally take for these elements and see which of the following is an anomaly. All of you are saying option A. Option A, carbon 12. Carbon 12 is a radioisotope. What is the atomic mass of carbon generally? If I ask you to calculate the mass of CO2, what is the mass of carbon?
No, ma'am, it's a natural isotope. Ma'am, sorry.
Yeah.
14C would be a radioisotope.
Yes, exactly. We solved a question about that also. Carbon 14 is the radioisotope. Carbon 12. So carbon has two isotopes, C13 and C14. C14 is radioactive. Phosphorus 32, sodium 23, and sulfur 32. So which would be the correct answer here? What is the atomic mass of sulfur? Okay, now I see people answering option B, phosphorus 32. That is the correct answer. So phosphorus 32 is the radioisotope of phosphorus. So the mass of phosphorus, the stable isotope, the natural isotope of phosphorus, it is the atomic mass is 31. So phosphorus nuclei has 15 protons in the stable isotope and 16 neutrons in so I'll just write, yeah, so P31 has 15 protons and 16 neutrons. Okay, and P32, it has 15 protons, same as P31, but 17 neutrons. Now you see, if you remember from the previous slide, I've told you that if the ratio of neutron to proton is very high, then what happens? The more number of neutrons or protons they start making the nucleus unstable. Now here the neutrons and protons were in balance, almost in balance, but here the number of neutron is in excess as compared to the protons, and those extra neutrons are making the nucleus unstable. And to regain stability, it undergoes a beta decay. What is a beta decay? I have told you, remember, in beta decay, one neutron gets converted into proton. So what happens? If one neutron gets converted into proton, what we'll have? We'll have 16 proton and 16 neutrons. And do you know which element has 16 protons and 16 neutrons? Sulfur. So P32 actually decays into sulfur, which is a stable form. Sulfur S32 is a stable nucleus. So the unstable P32 nuclei gets converted into stable sulfur nucleus, emitting a electron and a antineutrino. Okay, so this is a beta minus particle, that is the electron, and antineutrino is emitted out. Okay, so this extra neutron, it gets converted into proton, and in turn it emits a beta minus particle and an antineutrino. I hope this is clear to everybody.
Yes.
Moving to the next question, question number 19. The initial mass of an iodine isotope was 450 grams. Determine the approximate mass of iodine after 40 days if the half-life of the isotope is 8 days. Again, similar question. We have solved this already. So, quickly solve the question. I'll give you some time and then we'll discuss. Initial mass is 450 grams. What would be the approximate mass after 40 days? So you have to find N. N0 is given, T is given, lambda you can find out from T half. T half is given as 8 days. Very good. Mobini has already solved it. Option C. She's saying option C, 14.09 grams. Others also do the calculation. Tell me what is the correct answer. Okay, 3 of you have answered option C now. Others also write your answers. So your T half is 8 days. So lambda would be 0.693 by 8. This is equal to 0.086. Okay, and then you have to find the N. N0 is given as 450 grams, e raised to the power of minus of 0.09 into 40. I see most of you are answering option C. That is the correct answer here. So once you solve this, you will get the answer approximately around 14.09. Again, here you can get some some decimal place differences, but it's okay. So if you take it as 0.09, I think you will get the same answer. Just check once all of you are getting this answer. Some decimal place difference is okay as long as you're getting the correct answer from the options. If it is an MCQ, it won't affect. If it is a subjective type question, there is always a range given in such questions, so don't worry about it. Okay. So I see all of you have answered option C. So I hope this is clear. By now we have solved multiple questions similar to this. So I hope this is clear to everybody. Still, if anybody has any doubt, please ask. Yes, anyone has any doubt?
No.
Okay, then moving on to the next question, question number 20. After 17 hours, only 0.35 grams out of an initial quantity of 1 gram of a radioisotope remains behind. Its approximate half-life is. So time is given 17 hours, only 0.35 grams out of initial of 1 gram. So initial was 1 gram, final was 0.35 gram. So you have to calculate the half-life. So again, everything is given in the question. Do the calculation quickly. I'll wait for some time. I'll let you write the answers and then I'll start the calculation. Very similar. All the questions are, you can see it's based on one formula. So if you know that one formula, questions related to this session should be easy for all of you. So I'll also do the calculation together. N is equal to n0 e raised to the power of minus lambda t. So n is 0.35, n0 is 1, e raised to the power of minus lambda t. E raised to the power of t would be t is 17 hours. And that would be 1 by 17. I hope this is the answer everyone is getting. This will be lambda. And we have to answer t half-life. So t half would be 0.693 by lambda. Okay. I see you have answered option A. Okay, you are again getting decimal place difference. It's okay. 11.22. The most closest answer is 11.55. I got 11.55 when I did the calculation again. So 1.05035, sorry, 1 divided by 0.35. If you do this division, take the natural log and then divide it by 17. The value of lambda I am getting is 0.06. Are you all getting the same answer or you are getting something else? What is the lambda value
Yes,
you got?
lambda is 0.06.
0.06. So 0.693 by 0.06 is 11.55.
I took lambda as 0.06175.
So I told you.
Yes,
And
ma'am.
ma'am, I took
I have also
0.0618.
taken the lambda as 0.06175.
So when your answers are given in two decimal places, I would suggest you shorten the value to two decimal places. It would be easier for you to get a more closer answer. This is always necessary. So there's something called significance of decimal places. So whenever you are doing some experiment also, since all of you are science student, I'm assuming most of you are working in some lab. So when you're doing a experiment or any in any case, when you're doing some calculation also, you have to see the significance of the decimal place. So for the sake of taking, I can take it till nth decimal place, I can take 50 decimal places, right? But you should know where to do the truncation of the decimal place. So when you see here, the significance of decimal place is up to 2 decimal places. Because the options are given up to 2 decimal places, you take the value to 2 decimal places. That will simplify your life as well. That will make it easier for you to do the calculation. You don't have to type all the digits in your calculator. So if you take 0.06, the value of lambda is 0.06, you will get 11.55, because I just did the calculation again. So that's why I was doing the calculation, because I was again thinking that you might be getting a different decimal place. So you can see why you are getting a different decimal place, because you are not truncating your decimal places where it is necessary. So when you're doing an experiment, let's say you are using one particular instrument, you have to see the error value of that particular instrument. So if I'm using a weighing balance, the very common science instrument that everyone must have used in their labs. So if you're using a weighing balance, and my weighing balance has up to 4 decimal places, that means the last decimal place is always going to be error. In every weighing balance, you will see the uh, d value, the error value is given, that this particular instrument is significant up to 2 decimal places or 3 decimal places only. It's accurate up to that many decimal places. It's even if your weighing balance has 4 decimal places, does not mean it is accurate up to the 4th decimal place. Okay, there's always some error. So 4th decimal place will always have some error. So it is maybe accurate till 3rd decimal place or 2nd decimal place. So whatever is the accuracy of that particular instrument, when you're using the value, when you're using that value to do some calculation, let's say you are calculating moles, you have to use that 2 decimal place or 3 decimal place, whatever is the significance of that particular instrument, to do the calculation. That is how you will get a more accurate result, more significant result, not accurate, more significant results in your experiments as well. So this is also similar thing, like just something I wanted to share, because you guys have been uh, following different, like you guys have been calculating all the answers to different decimal places, so you should know where to truncate your decimal places. Okay, I hope that's
Okay,
clear to
ma'am.
everyone.
Yes, ma'am.
Yes, ma'am.
So I'll just show the solution. So here in this solution, I actually wanted to show you there's another way of solving these logarithmic equations. Since all of you are using calculator, this actually does not really makes any difference. But if you have a natural log of x, this can also be written in a form of 2.303 into log x, where log is in base 10, this natural log is in base e. Okay, so this is how we can denote. So your equation where natural log of n by n0 is equal to lambda t, that can actually change into 2.303 into log of n0 by n. Okay, so this is basically n0 and this is n. So you can do this, like this is another way of solving. So I've just added this solution so that you should know if any other question is in the form of log only, so you should know how to do the conversion. Other than that, I hope this is clear to everybody. Anybody has any doubt? This is the last question of this session, so we still have 10 minutes time left. So if you have any doubt, we can discuss. Any questions?
I have a doubt on
Yes.
one question from the assignment.
Yeah, tell me.
Um, Ma'am, the question is thorium 23290 is an alpha particle emitter with a half-life of 1.1402 into 10 to the power 10 years. Given a 0.601 gram sample of this thorium, how many alpha particles will it emit per second?
Okay, so in this, so you know what an alpha particle is. So alpha particle basically means uh, helium nuclei. So two protons are getting reduced and mass number is reducing by 4. Okay, so two protons and two neutrons. Okay, so your half life is given in that question, right? What is given in the question?
Ma'am, the half-life is given 1.1402 into 10 to the power 10 years.
Okay, half life is given. So from that you can get the decay constant, and your moles would be you will be able to solve the moles of thorium, I think, because the mass is given, right?
Yes, ma'am, 0.601 gram of thorium is given.
0.601 grams of thorium is given. Yeah, so from that you will get the moles of moles of thorium, and from that you can find out like what is the final nuclei that you are getting. So once you find the final nuclei, so what is the mass number of thorium? What is it given? 230, 238 or what? No, not 238. What is the mass number given? 236.
232.
232. Okay, so 232, from 232, whatever is the final number you are getting, that number would give you the idea how many alpha particle has emitted. So if from 232 you are getting 228, that means one alpha particle has emitted. If from 232 you are getting uh, two alpha particles are emitted, then the mass number will reduce by 8. So basically the new mass number will give you the idea of uh, how many alpha particles has emitted. Okay, I'll also have to look into the detailed solution to explain better. From 232 your thorium is 232. You have to basically find out the final mass number to find out how many alpha particles has emitted. Okay, I'll just check once. Just give me 1 minute time, I'll check. Let you know.